All right, example 4A, they're asking us to solve again. And if you're looking in the book, you may be tempted to use the power reducing identities because that's what they just gave you. That's what they just taught you, okay? I'm telling you, use the same thing and same ideas that we've been doing. Don't make it harder than it needs to be, okay? When I look at this, I see the difference of squares pattern. So I can factor this into cosine squared alpha minus sine squared alpha times cosine squared alpha plus sine squared alpha. Well, sine squared plus cosine squared is 1. And so instead of going the direction that they're trying to guide you and using these power reducing identities, and this would have been a really big, long, complicated problem, right away, this is gone. This is equal to 1. And then right here, I have cosine squared and sine squared. Now, you might be tempted to say that cosine squared is 1 minus sine squared, or that sine squared is 1 minus cosine squared. But if you recognize this, cosine squared minus sine squared is equal to cosine of 2 theta, okay? And so you can go either direction. It doesn't matter which way you do it, okay? I'm gonna change this to cosine of 2 alpha, and then of course this was a 1. Just so if you're watching this later, you remember that this was equal to 1. So we just have the cosine of 2 alpha is equal to 1/2. So where's the cosine 1/2? And again, they did not specify a region on this one. So we're back to all the possible solutions. So cosine is positive in quadrants 1 and 4, okay? So for this particular one, I have my argument. Cosine is 1/2 at pi thirds. And then in quadrant 4, this would be at 5 pi thirds. And this is just like example 4 from the last section, or excuse me, from section 5.3 when we first started solving. And so what ends up happening is now I have one step further to go. So I divide by 2. So alpha is equal to pi 6, and then I divide by 2, and alpha is equal to 5 pi 6. My period, because of the way I did this problem, is pi, okay? So my answers are going to be pi 6 plus pi n, and 5 pi 6 plus pi n. Now, if another person way back up here changed cosine squared to, actually I'm going to change sine squared to 1 minus cosine squared, okay? So I'm going to do this problem a completely different way. So I have cosine squared minus 1 minus cosine squared. And then this is going to equal 1 still. If I distribute that negative, this becomes a negative and this becomes a positive. So I end up with 2 cosine squared alpha minus 1 equals 1/2. So I add my 1. Divide by 2. Take the plus or minus square root of both sides. So, difference in my answer. Where is the cosine equal to the square root of 3 over 2? Well, it's equal to the square root of 3 over 2 at pi sixth. It's equal to a negative square root of 3 over 2 at 5 pi sixth. It's equal to a negative square root of 3 over 2 at 7 pi sixth. And it's equal to a positive square root of 3 over 2 at 11 pi sixth. Now, why did I only have 2 answers here and why do I have 4 answers here? Because now my period is 2 pi. And so my answers So let's say you got this answer, and this is what's in the back of the book. What you're going to notice is that your periods are different, okay? That this additive piece is what's going to change, okay? And so that's how you would notice that. If you have a question when you're doing your homework, if they are equivalent answers, you can certainly ask me, but you should be able to recognize the more efficient way of writing a problem.